Hi there, this is Carlo Carrano on the eleneasy.com channel on YouTube. Usually you see me working in the lab or doing other stuff like running tutorials, but this time I wanted to do a work that is a little different, a project that involves the usage of these devices. These are commonly used in the garden to do some work. There are several kinds of them, and they are all powered with the same battery pack. However, there is a problem with these battery packs. After 1 or 2 years that you use them, they start losing the capability of holding the charge. So when you attach them to the device works just for a few minutes and then it stops working. Since I am tired of all of this and I don't want to buy every 2 years a new battery pack, or more of them actually, I decided to do something to prevent using the batteries and use directly the power from the power grid to power up these devices, so I don't need to use the batteries anymore. So let's move to the lab now and let's see how I am going to modify this battery pack to use the power from the power grid and avoid using the batteries that go bad so much often. So this is the battery pack we want to work on. First of all, I'm going to measure the voltage over here to see which one of these is the positive side. So let's get voltmeter and let's measure it. So let's see, there's not going to be much because this battery is dead, but at least we can see which one is the positive side. So it looks like the positive is the one on the side and the one on the center is the negative. Yeah, as you can see, this way I'm measuring a negative value, and in this direction instead I'm measuring a positive value. So this is definitely the positive. Let me do this so we won't forget. Plus and minus. So now let's take that on the side. Let's open this pack and let's see if we can remove the batteries, like I hope I can. There we grab something to hold the screws and let's remove all of them. Well, it seems like this screwdriver doesn't work very well. Let's see if I can find something better. Maybe this. Yeah, this seems to work better, so let's use this one instead. There we go. No, this doesn't work either. Probably this one. Yep, that seems the right one. Okay, let's see if this works better. Yeah, good. I finally found the right screwdriver. See, these screws have this kind of head over here, which is difficult to deal with, but it needs this kind of screwdriver to be dealt with. So let's go with the other screws. There are 6 in total, so this is gonna take a little while. Hopefully not much though. We can get rid of that and that. Okay, this works just fine. So that's exactly what we want to use. Next screw. Okay, I'm having trouble with this. Come on. Again. Okay, I think I found the right screwdriver to use. This seems to work fine. It took a while. It looks like these screws have a head very peculiar. But now here I am, and I can do it easily in the right way. Okay, last screw. Done. And now let's see if we can open the pack. Here we go. Okay, so we have two pieces. There's this one, and okay, this jumped out. It should go this way. Okay, so this is the power pack. We need this piece because this is the one that will go into the tools that we have to power. So I'm going to need to disconnect this from here, and let's see, I'm going to do it. I'm going to cut this cable for now and try to cut this thing here. There we go. This can be totally eliminated, I think. There. So this is the battery pack that we don't need anymore. As you can see, it's made of a number of single small cells. Please don't throw this away in the garbage. These are inside here, there are very bad chemicals for the environment. So try to find a way to recycle it, so they will take care of it properly. This one goes back over here, I believe, somehow. Oh, the other way around, sorry. Here we go, that's the way it's supposed to go. Oops. Okay, so we still have the things over here correctly. We have to remember the external side is the positive. So let me use a label to that, so we can easily see it in the future, later on. There we go. Here is one. I'm gonna put it right here, so I won't forget. So this is plus and this is minus, so you can see it clearly now. Okay, good. So now what I'm gonna do is to get a power supply which is powered from the grid, and that produces an 18 volts DC voltage, and I will attach the DC voltage output over here, and then I will make a hole here so that I can pass through the cable of the power pack. So when this is closed, basically, I will still put this on the tool so it can work fine, but rather than having a battery pack inside of here, there will be a cable coming out that will go directly to the power supply, and from the power supply to the outlet. So let's see how to do that. Oh, by the way, I just remember that this piece is gonna fall off very easily, so I'm gonna glue it on the support so it won't move anymore, and this will help make everything work correctly in the future. whenever we use the pack, will be solidly glued over here, and there will be no issue to lose the connector. Okay, done. Now let's the glue dry up. In the meantime, let's move on with the project. Here is the power supply that I'm gonna use with this project. Rather than building one by myself, I found it cheaper to buy one already made of the correct power. Basically, I'm using a power supply of 18 volts, 10 amps, for a total of about 180 watts. This power supply can be easily found on eBay or on Amazon, and it costs just shy of 20 bucks. Building one by myself would have cost probably more, but this will perfectly suffice. So this is the one that we're gonna use. And okay, since you see it's all metal externally, I'm gonna build a box with my 3D printer made of plastic. So I will isolate all the components inside the power supply, and especially the location of the cables, because I don't want, of course, nobody gets a shock, electric shock, while using the power tools for the garden. While I was testing the completed device, I realized that I didn't take into account the fact that when the motor is started, it behaves more like a short circuit, and only after it starts running the current goes down to an acceptable value. With a battery pack there is no problem, because the battery can provide for a limited amount of time the high value of current necessary to start the motor. With a power supply, however, this is not true, because the power supply behaves by cutting the voltage in the presence of a short circuit, and by cutting the voltage the motor cannot start. After a little bit of thinking, I decided to add in between the power supply and the motor a motor regulator, which is the one in the present picture. This way, when the motor needs to start running, we can keep the rotation to the minimum using the regulator, thus allowing the motor to start running with a low value of current. Once the motor is running, we can adjust the speed to the regulator and set it to the max. I bought both the power supply and the motor regulator on Amazon. The links for both are in the video description below. Then let's go now to see how I built the plastic box that will contain this power supply. Here is what I did to build my plastic box for the project. Of course, you don't have to do that, you may just buy a box on your own, but since I have a 3D printer I decided to do that. So you see, it's a very simple construction, just a box with a cover and a couple of holes at the two ends, one that is going to be used to connect the box and its contents to the old battery pack, and the other side will be the cable that goes to the outlet. Here's the design. As you can see, it's very simple. I basically used the Minkowski transformation to round up the edges of the box, so nobody can hurt himself if these edges hit a person while he's walking outside in the garden. So basically what it does this is takes the cube and then modifies the edges, making them look like a part of a sphere. So that's how it works basically. Then on this cube I emptied the inside of it. Then I emptied also the edges over here to make sure that I could fit the cover. And then I created two holes, these two last instructions, 1 and 2, one for one side and one for the other. And then the other piece is just the cover, which is just a cube, cubic shape of course. This is perfectly square, there are no rounded edges, because this is supposed to go directly inside these excavated edges over here, so it should not pose any concern to whoever is working with it. Okay, first of all, we are going to cut a hole on the cover of the old battery pack, so we can let the cable that goes from the battery pack to the power supply go through. We'll make the hole right over here, and I'm going to use this drill to do that. Okay. So we have the hole, so we don't need this isolator anymore. That's the hole, and the cable can pass through very fine. Good. Let me clean up this mess and then I will get back to you now. So next step now is to solder these connectors over here. So let me clean up a little bit of insulator so we can do the job. Let's see. Okay. Now we are not going to use the green wire. Remember, this is the DC side, so it doesn't really matter if we have a ground. But we will need a ground on the AC side. So let's clean these cables. There we go. And now I'm gonna solder them. Now, since for DC current the standard is used black as negative, I'm gonna put the negative over here and the white over here, which is the white side on the positive. And I'm gonna have to solder these two cables. So I'm gonna use this here. I'm gonna make a little noise now because I turned it on the fan. So first of all, I'm gonna put some solder on the cables so they will easily attach to the connectors. Then I'm gonna use some soldering paste over here to help the solder attached to it. Let me actually do it this way. There we go. That should be plenty. And now let's thin the surfaces. Okay, they look good. And now let's do the soldering itself. There. Now the other one. Okay, this seems strong. The soldering points are shiny enough, so they tell me that everything is fine. Let's move to the next step now. Okay, now time to put the cover on the shell and close this up. But first, I'm gonna put a knot over here. This will basically prevent the connections over here, the one we just soldered, to break down, because the knot will basically absorb all the pulls from the outside. Oops, I keep losing this spring. Let's put it back over here. And here we go. Let's see. There we go. The cable comes out from here. It's solid. Now let's put back the screws that we removed before. Done. This is perfectly stable. This is still working, and now this is the piece that will be used to power every tool where I can connect this on top of it. So now we have to attach this end to the power supply. So let's do that. Here is the power supply, and you can see here is the label that identify each of the connectors. But since they are not really well visible, I created this extra label that I'm going to attach on top of the power supply to better identify all the connectors. Okay, so this is where I'm going to put it. Okay, so that's much better now, and I can see it from the top rather than having to turn around the power supply. So it's time now to make all the connections. First I'm gonna pass the cable that goes to the plug into the box and connect it to the 3 screws on the power supplies that corresponds to the light wire, the neutral wire and the ground wire, respectively the black, the white and the green wires. I'm also making a knot on this side of the cable to make sure that the pull on the outside of the box of the cable won't break the connections inside on the power supply. So now that I have checked that the power supply box fits well in the plastic box, I take it out again so I can complete all the connections. So in particular I unscrew now the DC connectors the power supply. I prepare the cable to connect the power supply to the motor regulator. Then I check that there is no short circuit on the cable that I just made. Then I screw the cable on the power supply side. And then I screw it on the motor regulator. Now what is left to do is to take the cables from the former battery pack and to put it inside the box. For this I have to move a little bit around the power supply box. Then I screw the cable from the battery pack into the motor regulator, making sure I connect it to the right places, the positive and negative. I position the regulator inside the box and I put a piece of cardboard in between the regulator and the metal box itself to avoid short circuit. So now it's time to... oh man, I forget to make the hole for the potentiometer for the regulator. Okay, I think I have to do it now with the drill. So what I'm doing now is making a hole with the drill for the potentiometer that belongs to the motor regulator. Okay, now I finally can remount everything correctly. Assembly first the motor regulator, in particular the potentiometer goes to the hole. And I lock it in place from the outside. Yeah, the washer is not necessary because the hole is just the right size, and also the thickness of the wall of the box does not allow me to put the washer, because otherwise I couldn't put that on top of it. So now the potentiometer is being positioned and I'm tightening up the nut. Don't need this anymore. Let's put the knob on top of the potentiometer. There we go. We can turn easily. Perfect. Now let's put back the power supply inside the box. Okay, being careful not to cut the wires now. It's not that easy, but it can be done, as you can see. There we go. So okay, I'm gonna put back the cardboard just in case the power supply box moves and go hitting the motor controller. I'm gonna glue it in place so it's not gonna move. And so everything should be sit in place safely inside the box again. Okay, let's put the cardboard in. There we go. Make sure the glue attaches well on the bottom of the box. It should be fine then. There we go. Everything should be in the correct place now. Just a little final adjustment to the cables, and now we can cover the box and glue it in place. So let me get some glue, which I will put on the corners like this. First corner, second, third and fourth. That should be enough, I believe. Okay, now we can cover the box. And to let the glue cure safely, I'm gonna put some tape to to block in place the cover of the box, and once the glue is dry and cured, then I will remove this tape. Okay, first side, now the second, third, and finally the last side. Here we go. What we can do now is to test the whole thing. So I just grabbed the tool from my garage, installing the former battery pack in place. Now let's power up the box. And as you can see, we can start with a slow speed and then increasing it a little bit at a time until it reaches the maximum. Note that if I put the knob of the motor controller directly on the maximum speed, the motor actually will not turn on because of the issue that we mentioned before about the motor being seen as a short circuit when powering up. Using a low speed allows us to limit the current inside the motor, even if it figures as a short circuit. And since the power supply is able to handle up to 10 amps, that works just fine. I really hope you liked this video and will give me a thumbs up for it. Also, if you haven't done that already, please consider subscribing to the channel to be informed when I post new videos. And please consider also to become a patron by going to my patreon.com/eleneasy and pledge a monthly small amount of money. You can also go for a single donation every now and then through my PayPal account. All the information to do so is in the video description below. This donation will help me greatly in providing more frequent videos of higher quality. Thank you for watching, and as usual, happy experiments!